Welcome back. Day 31 of the AI Native Work Challenge. Today, we're diving into something that is literally powering almost every major digital business right now, the modern cloud data warehouse, specifically looking at the Snowflake-style architecture. We're going to break down exactly how it completely changed the game for handling massive data. Trust me, by the end of this explainer, you're going to look at storing and analyzing information in a totally new way. Let's get right into it.
So picture this. You're at a company that's absolutely crushing it. Sales are booming. You've got millions of customer records, website logs piling up, and detailed financial data. It's great, right? Until Monday morning hits. Hundreds of employees log in, they all try to run their weekly reports at the exact same time, and bam! The whole system just crawls. Dashboards freeze up, queries take hours, and your data suddenly becomes a massive bottleneck. So how are modern, fast-moving companies actually fixing this?
Well, to solve this mystery, we first need to get clear on a really fundamental split in the data world. We have operational databases on one side and data warehouses on the other. Think of your operational database as the daily workhorse. It's built to run your live applications and process daily transactions. When a customer clicks buy, that operational database is doing the heavy lifting right then and there. But a data warehouse, that's totally different. That is a centralized hub built specifically for looking at the big picture, for pulling all that raw data together so you can run deep analytics and actually make sense of it all.
It usually goes a little something like this. Step 1, a company starts out with just a traditional database. It's no big deal, just a few users, some simple reports, everything is fast and snappy. But then, step 2 happens. The company scales up rapidly. Before you know it, in step 3, you're staring down millions, maybe billions of records. You've got the marketing team, the sales team, and the finance folks all hammering the system with complex dashboards at once. And it literally brings that traditional setup to its knees. Because frankly, you're just asking it to do way too much work at the exact same time.
Now, back in the day, fixing this slowdown was an absolute nightmare. The only way to scale up was to buy and manage more physical hardware. Your database was running slow? Well, you had to call up your vendor, order massive new physical servers, wait weeks for them to ship, physically rack them in a freezing server room, and manually migrate your data over. It was insanely expensive, painfully slow, and honestly, just a massive headache for the IT team.
But then, we get this massive technological breakthrough, and this right here is the core concept of our entire explainer today. The big idea was this: what if we separate storage and compute? Up until this point, the place where you stored your data and the engine you used to process it were basically glued together in this same physical box. Breaking them apart, that completely changed absolutely everything about how we manage data at scale.
Let's break that down with a real-world analogy. Think of storage quite literally as the physical floor space of a giant warehouse where all your goods are sitting. In our digital world, storage is simply the place where your data lives. It's the hard drive sitting in some massive cloud data center, quietly holding your millions of customer records, sales transactions, and product details. That's its only job, just holding things securely. Compute, on the other hand, is the muscle. If storage is the floor space, compute represents the workers, the forklifts, and the machinery zipping around to actually organize, pack, and analyze all those goods. In digital terms, compute is the processing power, your CPUs and RAM. It's what you actually use to run your queries, crunch the numbers, and generate those reports from the data sitting out there in storage.
And this is where the contrast gets really interesting. In traditional systems, the building and the workers were locked together. If you needed more forklifts, you literally had to buy a whole new warehouse building just to fit them inside. Crazy, right? But modern cloud warehouses separate them entirely. Your data just sits there perfectly still in central storage, and you can bring in as many, or as few, workers or compute power to that data as you need, totally independently.
What this separation gives you is incredible elasticity. Think about a supermarket on a Monday morning right before a big holiday. You've got this massive crowd showing up. A good manager doesn't just let a frustrating line form, they just open up more checkout counters, right? It's the exact same here. If thousands of employees suddenly log in to check their dashboards, you just spin up more compute power instantly to handle the rush. No need to order new hardware whatsoever. And honestly, the brilliant part is what happens when that rush is over. When everyone logs off and goes home at night, fewer people are asking the system for data. So you just close those checkout counters, you scale the compute right back down to a whisper. And through all this scaling up and down, your actual data, your storage, is perfectly intact, sitting safely in the cloud, completely unaffected by how many workers are clocked in at that moment. This independent scaling introduces a totally revolutionary business model: pay for what you use.
Imagine just renting a taxi for the exact 15 minutes you need to get across town, instead of buying a wildly expensive car that just sits in your driveway gathering dust for 23 hours a day. With a modern cloud warehouse, you aren't paying for massive compute power around the clock. You're just renting that heavy-duty processing power for the exact moments you're running those heavy reports.
Now, I do want to throw in a quick reality check here. Moving to the cloud isn't magically cheaper in every single scenario. Like, if you accidentally leave all your compute turned on at maximum power over a long weekend, you are going to have a serious heart attack when you see the bill. The real superpower here isn't guaranteed cheapness, it's absolute flexibility. It gives you this unprecedented ability to align your computing resources directly with your exact business demand, minute by minute.
So let's look at how platforms like Snowflake actually structure this in the real world. It all starts with your data sitting securely in one centralized cloud storage bucket. Above that, you spin up independent virtual warehouses, which is just a fancy term for your compute clusters. These separate clusters run your specific queries and analytics, and then feed those results right into your business dashboards, your AI models, and your daily reporting tools.
And this setup brilliantly solves that Monday morning traffic jam problem we talked about earlier. Look at these different teams. You've got finance needing massive compute for end-of-month reports. Sales just needs continuous lightweight compute all day for their live revenue dashboards. In the old days, finance running their massive report would literally crash the system for sales. But now, every team gets their own independent virtual compute cluster. They all tap into the exact same centralized data, but they use their own separate engines, meaning they never step on each other's toes.
Let's apply this to a real-world scenario. Say, a massive e-commerce giant storing 100 million orders and 50 million customers. During normal business hours, they just run moderate compute to handle standard daily analytics. But then, the big monthly reporting cycle hits. They seamlessly dial their compute up to maximum for a few hours to crank through the heavy lifting. Then, at 3 a.m., when basically no one is working, they dial it way down to almost zero. It's totally fluid, and they only pay for the heavy lifting when they actually need it.
So why did the entire tech industry shift to this model? Basically, data volumes just exploded. Suddenly, every single employee needed their own BI dashboard, and they expected lightning-fast answers. Managing physical hardware just became an impossible task for scaling businesses. But keep in mind, this doesn't mean traditional databases are dead. Your operational databases are still absolutely vital for actually running your apps and taking those customer orders. The shift we're talking about is all about how we handle the heavy analytical workloads.
Now, you shouldn't just run out and buy a cloud warehouse because it's the trendy thing to do. It really makes sense specifically when you check a few boxes. You need to have massive amounts of data, hundreds of users trying to run analytics all at once, data coming in from a bunch of different software systems, and, crucially, highly fluctuating compute demands throughout the day or month. If that sounds like your organization, well then a cloud warehouse is a total game changer.
So the really crucial point I want you to walk away with today is this shift in your mental model. We are completely moving away from that rigid, old-school approach where you had to blindly buy hardware, lock your storage and processing together, and manually scale when things inevitably broke. The new mental model is so much more elegant. Centralized cloud storage paired with totally flexible compute. It gives you the power to scale instantly and analyze literally anything, anytime.
All right, let's quickly recap the 5 big takeaways for your AI native work challenge today. Number 1, a cloud data warehouse is your central hub for analytics. 2, storage is simply where your data lives. 3, compute is the muscle used to process it. 4, separating those two things is the key to ultimate flexibility. And 5, the cloud allows you to scale those resources strictly based on your actual real-time demand.
And that brings us to the big picture here. The biggest change we've talked about today isn't just a basic IT upgrade. It isn't just taking an old database and sticking it on a server somewhere else. It is a complete transformation in how modern organizations conceptualize, interact with, and extract real value from their business data. When you separate storage and compute, you unlock the true potential of your information.
Fantastic work grasping these core concepts today. You now understand the fundamental architecture powering modern data analysis. Day 31 of the challenge is officially complete, but I want to leave you with one final thought. Now that you know you can spin up infinite compute power to analyze virtually anything at a moment's notice, what is the massive data problem you're going to solve first? Keep up this incredible momentum, and I'll see you in the next explainer.